Good evening, students. Today we are going to start a new chapter, that is acids, bases and salt. Now first of all the question comes, what is an acid? Now acid means a substance which is sour in taste. That is said to be as an acid. A substance which is sour in taste. But don't taste the acid, let me tell you. Alright, never taste it. Because in chemistry lab, you do not know which substance is toxic or non-toxic, so hence never taste it. Just for the reference I am saying you. So acids which are sour in taste and bases are bitter in taste and salts salty in taste. No need to say about it. So this is just a general what you can say definition. Initially when we are not knowing about details about acids, bases and salts. So we used to classify in this particular way. The substance which are sour in taste are acids and the substance which are bitter in taste is nothing but is your bases, and the substance which is salty is salts, we can say that. So bitter in taste means, now you might be wondering, bitter means for example sodium hydroxide, potassium hydroxide and all the substances. NaOH, you know, it is being present in your soap. Alright, so just a little bit, if you taste the soap, you will see it is slightly bitter. It is having a bitter taste. Alright, that particular, we can say that. Clear? NaOH. So difference of NaOH, we can say. Now in this way, but this is not the definition of acids, bases and salt. This is just a general concept I said. Now what is an acid? Alright, what is an acid? You better write it down. Alright, better write it down, I am telling you. Acids are those substances which gives H plus ion or hydronium ion as the only positively charged ion in its solution. Alright, acids are those substances which furnishes H plus ion. You know what is H plus ion? H plus ion or H3O plus ion, that is hydrogen ion or hydronium ion, as the only positively charged ion in its solution, in its aqueous solution. That is called as an acid, we can say that. I think you got it. So examples of acid is HCl, we can say HNO3, we can say H2SO4, we can say, and so many, CH3COH, carbonic acid, H2CO3 and so many. Okay. Now what is a base then? What is a base? You can say base according to Arrhenius. Alright, there are different concepts are there. Different scientists have given different concept. What I said you? Arrhenius. He was a scientist. Arrhenius. He only gave this particular concept, that an acid is a substance which furnishes H plus ions as the only positively charged ions in its solution. We can say that. Similarly, Arrhenius says that a base is a substance which gives hydroxyl ions, OH minus ion, as the only negatively charged ions in its aqueous solution, OH minus ions. Or you can say in other way also, the substances which reacts with acids, means the oxides and the hydroxides of the metals which reacts with acids to produce a neutral substance, that is salt and water, are known as bases. We can say that. I am saying very slowly, you may write it down. The substances, that is oxides and hydroxides of the metals which reacts with acids to produce a neutral solution, are known as bases, we can say that. Now here also you must understand it, that all bases are not soluble in water. The bases which are soluble in water, they are known as alkalis, remember it. So all bases are not alkalis, but all alkalis are bases, we can say that, because all bases are not soluble in water. So alkalis are what? That is sodium hydroxide is soluble, potassium hydroxide is soluble, ammonium hydroxide is soluble. So they are known as alkalis. You can consider to a certain extent calcium hydroxide also, but that is sparingly soluble, not so highly soluble, sparingly soluble, we can say that. Okay. So in this way they are alkalis, they are the soluble bases. We can say that these bases are soluble in water and they will give you OH minus ion as the only negatively charged ion in its solution. We can say that. I think you got it now. What is a base and what is a salt? What is the definition of a salt? Salts are those substances which contains a positively charged ion other than H plus ion and a negatively charged ion other than OH minus ion. It's known as a salt. Again I repeat, salts are those substances which contains a positively charged ion, alright, other than H plus ion. Let us say positively charged ion is sodium, Na plus, and negatively charged ion other than OH minus ion, let us say Cl minus. So what you get? NaCl is a salt, KCl is a salt, K2SO4 is a salt, KNO3 is a salt. Got it? That is known as a salt. We can say that. So in this way you got the definition of acids, bases and salt. We can say that. Okay. Now next is, I said you this particular the definition of acids and bases on the basis of Arrhenius concept I have said you. Now some other scientist was also there who gave the concept, that is Bronsted-Lowry. We can say that. We can say that Bronsted concept also we can say that. What I said? Bronsted-Lowry. Now according to Bronsted-Lowry, listen carefully. According to Bronsted-Lowry, acids are those substances which are proton donors. The substances which are proton donors are known as acids. Like see HCl, it gives H plus ion. So what? HCl is an acid, proton donor. Then what is a base then? Bases are those substances, according to Bronsted-Lowry, bases are those substances which are proton acceptors. Which accepts a proton is known as a base. That means ammonia, that is NH3, when it reacts with H plus, it forms what? NH4 plus. So ammonia is a base because it's a proton acceptor. And HCl, it donates a proton. So it's a proton donor. We can say that. So according to Bronsted-Lowry, this is an acid and this is a base. This was a concept. Okay. Now next is another concept we are having. This is the Lewis concept. According to Lewis, what is an acids and bases? This is the what you can say the new concept. We can say that the Lewis concept of acids and bases. Now according to Lewis, he divided the substances in chemistry into two halves. One is acids, another is bases. According to him, there is no neutral substances. So what is an acid? Acids are those substances which donates a pair of electrons, we can say that is which accepts a pair of electron. They are known as acids. Again I repeat, according to Lewis, the substances which accepts a pair of electron. Got it? So that is known as an acid, and the one which donates a pair of electron, that is known as a base. So we are having Lewis acid and Lewis base. So what is that? Lewis acids are those substances which are electron donor, a pair of a pair of electron acceptor. A pair of electron acceptor as acids. Lewis acids are, and Lewis bases are those substances which are a pair of electron donor. We can say that. Again I repeat, Lewis acids are those substances which are a pair of electron acceptor, and Lewis bases are those substances which are a pair of electron donor. We can say that. Okay. Now you might be wondering, what is that? See, here what I said you, according to Lewis, he divided the chemistry into two, that is Lewis acids and Lewis bases. Okay. So here what you can find is that HCl, of course, is a Lewis acid. Got it? Then AlCl3 is a Lewis acid. Clear? Now that is ZnCl2 is a Lewis acid, HNO3 is a Lewis acid. Alright, in this way H2SO4 is a Lewis acid. Now you might be knowing this is an acid, where from this becomes an acid. Because if you see the structure, if you draw the structure of aluminium chloride, aluminium has got 6 electrons in the outermost shell. 6 electrons. Aluminium, you write the electronic configuration 283, atomic number. It is having 3 electrons from its own side, and it gains 3 electrons from 3 chlorine. So it is how many having electrons? 6 electrons, aluminium, in its outermost shell after forming aluminium chloride. Now it is having deficiency of how many? 2 electrons, because it needs to attain the octet structure. Octet. So hence it borrows 2 electrons. So what I said? Electron acceptor, a pair of electron acceptor. So Lewis acids means the substances which are having deficiency of electron. Listen carefully. The substances which are having deficiency of electron. It may be neutral substances, or it may be what you can say charged also. Like HCl will give you H plus ion. H plus ion requires 2 electrons. You have studied in chemical bonding. HNO3 will give you H plus ion. H plus ion requires 2 electrons. You can say that to become stable. So in this way, same thing of H2SO4. So in this way, Lewis acids means the substances which are pair of electron acceptor. Pair of electron acceptor, not a single electron. Pair, remember it. Pair of electron acceptor. It may be neutral substances also. It may be what you can say charged substances also. We can say that. Clear? Now Lewis base. Lewis base water is a Lewis base because water is having, in oxygen we are having 2 lone pair. Ammonia is a Lewis base. Ethyl alcohol C2H5OH is a Lewis base. Then ether, that is C2H5O C2H5 is a Lewis base. Now you must be wondering how it is a Lewis base. See here, water is having 2 lone pair, 1 lone pair it will give, it can give. Ammonia, 1 lone pair it can give. Alcohol, same thing, ether it can give. Similarly, sodium hydroxide NaOH is a Lewis base. KOH is a Lewis base. Got it? Oxygen is having lone pair of electrons in it, present in it. We can say that. So in this way, the substances which are pair of electron, what you can say, donor. Got it? Same thing. Here we are also having the neutral substances as well as the charged substances. Which charge? Negatively charged. Here we charge positively charged, because positive means it is going to accept. Negative means it is going to donate, because it is having excess, it will give. Got it? Negatively charged means it is having excess, it will give, it will donate. Got it? NaOH, it will dissociate to give you what? Na plus OH minus, it will give electrons. So hence it is known as a what? Lewis base. But water, why it is called as a Lewis base? Because as you can see, oxygen having 2 lone pair, it can donate a pair of electrons to it. You have seen it also in hydronium ions formation. In chemical bonding, water is donating a pair of electrons to H plus ion, okay, to form H3O plus ion. So in this way, it acts as a what? Lewis base. So understood what's the Lewis acid and Lewis base? Okay, fine. So we have studied Arrhenius concept, Bronsted-Lewis concept, and Lewis concept of acids and bases you have studied. Okay, thank you very much.